Hi everyone, let's finish up our topic on acids and alkalis. Today we're going to deal with neutralization. So by the end of this lesson, you will be able to define neutralization. Then finally, you will be able to appreciate the importance of neutralization in everyday life. So what is neutralization? Neutralization is a reaction between an acid and a base in which only a salt compound and water is produced. So we are saying neutralization is where you add an acid and a base, and what you're going to produce is you're going to produce a salt and water only. And the word equation can be written as follows. So whenever you add a base and an acid, it will always give you a salt and water. Now, this can also mean it can be an alkali plus an acid. It will still give the same things. I'm sure by now we know that. And a base is just the general term that refers to soluble and insoluble bases. All right. What happens when an acid is added to an alkali? Obviously, I expect people to say neutralization, but we have to add more details than that. So let's look at this here. This is a setup where we can use to carry out a neutralization in the lab. So what you can see here, in here, there is actually an acid. So in here, this is what we call a burette, and inside here, there is an acid. So when you open this tab here, you are going to be putting the acid in here. Now, remember, from the colors of the indicators, we learned about indicators, and we said an indicator is simply a chemical substance which changes color in an acid or in a base. So the indicator that we are using here is what we call bromothimo blue, or also known as bromocresol blue. Okay, so now this, it shows a yellow color in an acid and a blue color in an alkali. So in this conical flask here, what we had was an alkali. As you can see, the pH was more than 8. Remember our pH scale, a range of numbers from 0 to 14. So 7 is in between, therefore it's the neutral. Every number that is below 7 indicates an acid, and every number that is above 7 indicates a base. So let's look at what is happening here. So in short, we are saying when you are adding, since here we are saying there's an acid, so when you are adding an acid to a base, as you can see, the color is even blue. So an alkaline is simply a soluble base. So don't be confused when we interchangeably use the term alkaline and base. It's simply one and the same thing. The difference is one is soluble, one is insoluble. So when you are adding, what is happening here, you are raising, you are reducing, because an acid has got a lower pH. So when you are adding an acid to an alkali, it means you are reducing the pH. Okay, you are reducing the pH. So it will reach a point where the amount of acid, or in terms of concentration, also the amount of acids in terms of concentration equals the amount of alkali in terms of concentration. So at that point where everything is equal, exactly the same, then a neutralization is going to take place. Okay, so the neutralization will take place here. That's why the color here is even green, and the pH is in this range of 6 to 8. Otherwise, it's supposed to be 7, but because you are using your own hands in pouring these, during this experiment, you are doing an estimation. So it's either you added more or you added less, because what is happening is the more acid you add here, the color will start shifting to yellow. So when it is neutral, it means it is neutral. This solution is neither an acid or an alkaline. So when you continue adding an acid, it means this solution now, it will begin to change into an acid. Therefore, the color will even indicate yellow. And when that happens, just know that the pH has reduced. The pH has reduced. So to answer the question, we are saying when an acid is added to a base or alkali, the pH decreases. Reason is simple. pH of acids is less, whereas the pH of alkalis is high. So when you are adding an acid to a base, it means you are reducing the pH. Okay. Addition of an acid to an alkaline reduces the pH. So the pH decreases. I hope that one was clear. Okay, let's look at the opposite. What happens when an alkali is added to an acid? Now, let's look at our setup here, and we are using a different kind of indicator. Here, we are using an indicator known as phenolphthalein. Okay, the indicator we are using is phenolphthalein. Okay, so phenolphthalein, it shows a colorless color in an acid and a red or pink. So it shows red or pink, sometimes purple. So red, pink, purple, in that range. Those are the colors in which it will show in an alkali. So now let's observe here. Here in our burette, we have the alkali, and here we have the acid, which means that the pH is actually less than 7. So we have the acid, which means that the pH is less than 7. So when you begin to increase the alkali here, it will reach a point where the concentration and volume, the concentration and amount of the acid and the alkali is exactly the same. So there, neutralization is going to take place, meaning in here there will be a salt and water only, and therefore the color will be a faint pink or a faint purple. Okay, so faint color. And then if you continue adding the alkali, because the alkali has got a higher pH value. So an alkali has got a higher pH value. So because you are adding an alkali which has got a higher pH value to an acid which has got a lower pH value, it means that you are increasing the pH. So the pH will be moving from the lower numbers which are less than 0 to which are less than 7 rather, sorry about that, which are less than 7. You are increasing it towards 7. Since the pH is less than 7, when you begin to add an alkali, it means you are increasing the pH towards what? 7. And that is what we call neutral. And that one will be called the endpoint. So when you continue adding the alkali, it means the pH will keep on rising until it exceeds what? 7. And when that happens, it means it has become what? It has become an alkali. So to answer the question, what happens when an alkali is added to an acid? The answer is simple. The pH increases. So addition of an alkali increases the pH. Addition of an acid decreases the pH. All right. Why are we talking about neutralization? Let's look at some sample applications of neutralization in our everyday life. So number one, neutralization is used in indigestion relief. I'm sure as a child, you've had a situation where digestion cannot just take place normally. In some ways, we say constipation. Maybe you are constipated, digestion is not happening properly. So here is an application of neutralization. Let's see what happens. Okay, so indigestion, like I said, things are not being broken down properly so that the normal life processes can take place. So indigestion, that one actually, it comes with some pain. Okay, it comes with some pain. So as you can see, this is in the small intestines there, and then the region of pain from indigestion. So there will be a bit of some pain. Okay, there will be a bit of some pain, as you can see in the diagram here. Now, what happens is you'll be given a drink of sodium hydrogen carbonate solution or baking soda or or any indigestion tablet. So when you take it there, this one, because maybe there's too much acid, so the acid level here will be reduced. You are going to have a neutral environment. So when the environment is neutral, then that problem is going to disappear. Okay, so the indigestion can be caused maybe by too much acid that is being produced in the walls of the stomach, or you ate a lot of acid food or anything. So because we are adding the sodium hydrogen carbonate, this one is more like a base. So this one is going to increase the pH. So up to a level where it is neutral, and then digestion will start taking place normally. So one application is curing indigestion or indigestion relief. Number two, treating insect stings. So we have quite a number of insects in our environment. We've got the honeybee, we've got the wasp, we've got the yellow jacket, we've got the fire ants, and the hornet. All these are different ants. So what happens, for example, when a bee stings you, it injects you with a certain acid. So we're saying sting can be neutralized by what? Rubbing on a lotion which contains an alkali such as zinc carbonate or baking soda. So we are saying when a sting, when a bee stings you, it injects you with some acid. So that acid is the one that causes irritation on your body. And to cure that, you just need to take a base or an alkali so that you can neutralize that acid. For example, there are some lotions which are given, or we are saying, so these lotions, they actually contain an alkali such as zinc carbonate or baking soda. Okay, let's also note that when a wasp stings you, so wasp stings, them they are opposite. So here I was saying when a bee stings you, it injects you with some acid. But when a wasp stings you, this one is different. It injects you with what? With an alkali. So also when it injects you with an alkali, it's going to cause an irritation. Now, get the idea. Someone might be wondering, why is it that when this one stings you with an acid, you take an alkali? When the wasp stings you with an alkali, you have to take an acid. The logic is simple. Mixing an acid and an alkali brings about neutralization. And neutralization is the ideal condition which is needed for normal life processes, normal organisms to continue with their normal life processes. They require neutral conditions. This is why when there's too much acid, you need to apply an alkali to neutralize the acid. When there's too much alkali, you need to add an acid to neutralize the alkali. Okay, so please get that into your mind. Number three, soil treatment in agriculture. So, like I've been saying, most plants grow best when the pH of the soil is close to 7. So, it should be around the neutral pH, 7, 7 point something, 8, around that. So, if the soil is too acidic or too alkaline, plants grow badly or they do not grow at all. So, neutralization is used in agriculture. So, having this knowledge, make sure that you educate the people around at home. It is important to check the pH of the soil so that you determine whether what you are going to grow is going, what you are planting is going to grow or not. So these things is not about faith, but it's about practicality, science. When you're growing crops, there's nothing like faith is the substance of things hoped for. Never, never, never. Agriculture, we are dealing with science. So take the pH of the soil so that you ascertain whether what you're growing, what you're planting is going to grow or not. Remember, it's about having neutral conditions. Fourth and the last one, at our level, we are saying neutralization can also be used to treat the factory waste. So we have got a lot of companies that are doing a lot of chemicals. They are making a lot of different things, fertilizers and all that. So when they are done, they usually dispose of their wastes to nearby rivers. Now, what happens is these wastes, they are usually acidic. So because they are acidic, when they are dumped into rivers, they can kill the fish and other aquatic organisms. Therefore, we can treat these rivers by adding some alkalines so that we can neutralize the water. One common alkaline that is used is actually slacked lime. Okay, slacked lime. So these have been the importance of neutralization. Make sure you go through this video, pause, memorize, think, try to analyze and understand everything. We interact with these things in our everyday life. In the homes, your parents perhaps have even used these techniques. So it's just for you to actually practice. All right, guys, thank you for listening to this lesson. Ensure to mask up. COVID-19 is real.